Hey everyone, how are you all doing? Welcome to the Java tutorials, wherein I cover most methods, concepts related to Java 17, the latest long-term support version. Today, we're going to talk about functional programming. What is functional programming in Java? They have been introduced since Java 8 onwards. So, what is functional programming? Functional programming is a paradigm that treats computation as the evaluation of mathematical functions. What basically, in short, what it means is that functions now are first-class citizens of any class. It supports functions to be passed as parameters to another functions as return value of another functions. Okay, so that's how it becomes what you call first class citizens of any class. Earlier, before Java 8 or before functional programming was introduced in Java, we could pass only objects as method parameters or as return values, like objects and primitive data types, right? But now you can pass a function within a function as a parameter, as a function parameter, and also a return type. We're going to see examples of it, but for now, just hear it out, okay? So what are some key concepts? So pure functions, okay? That's a key concept. Now, what does it mean is that it has no side effects. What it means in short is if you pass any parameter to the function, the values of those parameters will not change. The function itself will not modify the value of the parameters. This is one of the concepts of good programming or best programming practices, that a function does not have a side effect of any, does not change the values of the parameters that is being passed to it. That is exactly what follows to the next one, which is immutability. Okay, it is the practice of creating data structures that cannot be changed once they are created. Because then you know that once it's created, the value will not change, and the program itself can operate based on the assumptions that this object or this value or this variable will have this value. Higher order functions are functions that take other functions as arguments or return functions as results. This is what I was talking about. Streams are also powerful tool for processing data. I did cover in detail streams and optionals in the previous lecture. If you haven't seen it, you can go and watch it. Now, that naturally brings us to functional interface. That's how Java is trying to introduce functional programming. What is a functional interface? Now, interfaces are nothing new. Basically, interfaces in Java are how you implement contracts. They have all abstract methods. Regular interfaces can have more than one abstract methods, but functional interface will have just one abstract method. It can have many other default methods it's allowed to have, but abstract method is just one. Okay. This is the main difference between functional and regular interfaces. Like regular interfaces, we have many regular interfaces, but those can contain or allowed to contain more than one abstract methods. So these are the main characteristics: single abstract method, and also it can be implemented using @ functional interface annotations. Like see here, it has only one abstract method. And now the only advantage of having this annotation at functional interface is The compiler knows that it's a functional interface and it can predict its usage. And what's going to happen is if you try to add more than one abstract method, it will complain. The compiler will complain, oh, this you intended it to be a functional interface, and functional interfaces are allowed to have only one method. Okay, so that's the advantage of having the annotation. Otherwise, it doesn't matter. They're optional. See here, for example, lambdas and method references. See here, you're defining one function, my function add. It takes two parameters, and what it does with the parameters is sums, adds them up, and returns its value. And so, say, for example, this multiply, integer dot multiply, it's calling itself, it's calling a method, multiplying the parameters. We are going to see these in actions just in a little while. Actually see how to use them, different functional interfaces that are there in Java. What are default methods? Default methods are methods with implementations. Say, for example, here. So here, this is an interface which is, we have named it as calculator, has exactly one abstract method and an default implemented method. So let's say square root, what it does, it returns the square root of the integer which is passed to it. This is just an example of a functional interface. And as you can see, there is no functional interface annotation here. We are going to see everything in example very shortly, very shortly. Some examples of functional interfaces that Java comes already with it. There is a predicate that returns a Boolean value, function that takes one or more arguments and returns a single value. A consumer is a function. See, all four are functions. That's the common thing. But each one does a little bit different thing. Predicate returns a Boolean value. Function returns a single value. It could be Boolean or anything else, but it returns a value. Consumer takes one or more arguments but does not return a value. So it consumes the value, the arguments that is sent to it. Supplier does not take any arguments but returns a value. So that's how we have all the fours. Okay. So now let's see everything in action here. So if you can see each one, we'll run the class. So a predicate example. So as we saw, predicate will take and return a single value. So see, this is how you define. This is just nothing but an integer of numbers. This is how you define a predicate. Its type is integer. Just what it is doing, a simple function is that is even, it returns true or false. So it takes one parameter number and it returns the output of this expression, whether the number divided by 2, whether the remainder is 0 or not. Okay, and see how we use it. So you have list of numbers, so list of even numbers. We take these numbers, create a stream, filter. See, this is how you're applying is even here, the predicate. So it's returning a Boolean. See, this even takes a value, returns a Boolean. Okay, and then you're doing nothing but just collectors.toList, collecting all the integers that are part of this numbers array, numbers list, and collect it and give it here in even numbers. So if this is the list, it will have 2 and 4, right? Because only 2 and 4 are even. So we're going to see that in action. Next one, let's see consumer. So consumer consumes and does not return anything. That's the definition of a consumer. So here we are defining a consumer, just the name of the consumer function. What it does, it takes a parameter. This is for an example, it's doing this. It could do anything, right? Any functionality. So, and then you pass the function name here, names.forEach. And what it's going to do is whatever it's passed, it's going to apply this function and print it. And as you can see, it's not returning anything. It's used in the termination operation of this stream. So for each is a termination operation. Supplier takes a value and returns a single value. Okay, takes one or more values and return a value. So just this is nothing but random number supplier. You pass it in. Oh, sorry, it does not take any value, but returns a value. So here supplier, there's a single method called get. So what it'll do is every time you run this, it'll generate a random number and give it to this. Just printing the random number. And a function takes it and returns one value, a single value here. So nothing but just the length. We're defining string length. Okay. And then how do you invoke a function? You call apply to it. Okay. So let's one more time go through it. For a function, it returns a value here. You have to call the apply method of the function on the function interface, and which returns the value, and it will return the value. For a supplier, there is a single method called get. So for function, it's apply. For supplier, it's get. Consumer doesn't have anything because it consumes, does not return anything. It will perform some operation and that's it. Okay, so you just have to call the consumer function. Here, same thing for the predicate is even, you're just calling the function. Okay, so for function and supplier, you have to, in order to get the value, you have to call the function. So for supplier, it is get. For function, it's apply. But for the other two, for predicate and consumer, you can directly use the names. Okay, let's see it in action. So here it is. So for the first here, it prints 2 and 4. Okay, let's do one thing. Let's debug it so that we can see. Here. Yeah. Okay, so let's debug this. So we can stop and talk about it. Okay, here. So in the first one, as you see, even numbers, it just has 2 and 4, right? That's because that is what it was. Now next, it will just print the names. Go ahead. It will stop here. Nothing but if you see in the console, it would have printed the name. So this was the first example output, 2 and 4. This is here, Alice, Bob, Charlie, David. Alice, Bob, Charlie, David, nothing more. Next up, if we go, it will print any random number. See here, this is 83 for now. If next time when we run, it could be anything else. And the last one. So here the length is 13. See, you can see here in the debug mode, the length, hello world is 13. Okay, so this is how, this is what it's going to print. Basically, the line would say the length of hello world is 13. Okay. Hello world is 13. That's all. Here, let's just change this a little bit and see equal to or not equal to 0. Not equal to 0. So now I'm expecting, which means odd numbers. So I'm expecting 1, 3, and 5 here. So if I remove this, there you go. And I can change the string. Okay, let's see. Debug it again. So see here now, the variable name I should have changed, but it's now odd numbers. 1, 3, and 5 now it has, right? Here it'll just print name size 3, Alice, Charlie, and David. Random number, it would have printed, see, last time it was 83, this time it's 88. And now the last one, it would say the length is 24, input is this. And if you run here and see on the console, length of Java functional interface is 24. So this is how you use functional. Again, for function, you're going to use apply to apply the function or the functionality. For supplier, you're going to use get. Supplier does not take any input but returns a value. Function takes an input, performs some operation, and returns a value. Consumer does not return any value, just consumes. Predicate returns a Boolean value, whether it's true or false, okay, based on the function. So that is all about functional programming. Again, there are lambdas that you can use, like for example, in streams, we used a lot of lambdas, stream programming. So we could use there, okay? So that is all about functional interfaces and functional programming in Java, wherein now functionals are no longer just methods. They are first-class citizens, which means they can accept parameters. Any function can accept a function as parameter. Any function can return a function as parameter. So that's the big change. It makes our code more concise, easy to read, easy to handle. So that is it about it. These will be there. This code will be there on GitHub repository. Feel free to download it and play around with it, make changes. Okay. And thank you for listening. See you all again in next lecture. Thanks.